Hi, and welcome to the next section of this course, Identifying Groups of Data Using Clustering Methods. In this section, we will first get introduced ourselves to clustering, and then move ahead to learn about hierarchical clustering. After that, we will look at partitioning-based clustering methods, or the k-means algorithm, and partitioning around the actual center with k-medoids clustering. At the end, we will perform clustering using Gaussian mixture models. Now we move on to the first video of this section that deals with Introduction to Clustering. Here we will see similarity and dissimilarity measures, also the methods for grouping objects. Clustering involves identifying groupings of data. This is possible thanks to the measure of the proximity between the elements. The term proximity is used to refer to either similarity or dissimilarity, so a group of data can be defined once you have chosen how to define the concept of similarity or dissimilarity. But what do we mean by similarity and dissimilarity? By the term similarity between two objects, we refer to the numeral measure of the degree to which the two objects are alike. Consequently, similarities are higher for pairs of objects that are more alike. Similarities are usually non-negative and are often between 0 and 1. On the contrary, by the term dissimilarity between two objects, we refer to the numerical measure of the degree to which two objects are different. Dissimilarity is lower for more similar pairs of objects. Frequently, the term distance is used as a synonym for dissimilarity. Just like similarities, dissimilarities sometimes fall in the interval 0 to 1, but it is also common for them to range from 0 to infinity. Once you have chosen a way to calculate the distance, we have to decide how to form groups. Two main algorithm families can be identified: hierarchical clustering and partitioning clustering. Hierarchical clustering works by doing a data hierarchy, while partitioning clustering works by making a data space partition. Let's first talk about hierarchical clustering. In hierarchical clustering, clusters are constructed by recursively partitioning the instances in either a top-down or bottom-up fashion. We can divide these methods as agglomerative algorithm and divisive algorithm. In the first one, the solution is obtained from individual statistical units, while in the divisive algorithm, all units are the same class, and at each subsequent iteration, the unit most dissimilar to the others is assigned to a new cluster. Both methods lead to the formation of Dendrogram, representing a nested grouping of objects, and the similarity levels at which groupings change. A clustering of data objects is obtained by cutting the dendrogram at the desired similarity level. The merging or division of clusters is performed according to a similarity measure, chosen so as to optimize a criterion. In this figure, you can see a recursive partitioning of instances in the formation of a dendrogram. The next one is partitioning clustering. So, partitioning clustering decomposes a dataset into a set of disjoint clusters. Given a dataset, a partitioning method constructs several partitions of the data, with each partition representing a cluster. These methods relocate instances by moving them from one cluster to another, starting from an initial partitioning. This figure shows how a partitioning clustering constructs several partitions of the data. In partitioning clustering, we select a set of parameters in advance. These parameters are then adjusted to optimally satisfy a chosen criterion of separation and compactness of our clusters. In this way, a hidden feature of the data can be highlighted, revealing the partitioning key. Typically, this leads to minimizing a measure of dissimilarity in the samples within each cluster, while maximizing the dissimilarity of different clusters. In this video, we have learned about similarity and dissimilarity measures, along with the methods for grouping objects.